Jai Hind everyone, myself Ankita, Faculty of Department of IT, AKGEC. Today I will be discussing about logical addressing that is part of Unit 3 of Computer Network course BCS 603. So today I will be going to discuss introduction to the topic, then what is IP address, what are the different type of IP addresses, classful addressing, subnetting, and finally classless addressing. We will also be discussing some numericals. Now basically when we talk about network layer, these are the responsibility of a network layer. The purpose of our data link layer was to ensure hop-to-hop delivery. So whenever we are sending a packet from a sender to a destination, the intermediate routing is done by your data link layer. But when we talk about source to destination delivery, our network layer comes into action, which ensures the packet that is started from source reach the destination. So these the most important feature of a network layer is your addressing. Addressing means whenever we post a letter, in fact, if we talk about normal letter, when we post a letter, we write the sender address as well as receiver address. In the same manner, when we are sending a data packet from a source to a destination, we should be assigning the source and destination an address, and that address should be a unique address, and we call that address as IP address. Obviously, when you are sending a packet to different nodes, now these nodes should have an address that should be unique in the network. So logical addressing is basically the assignment of unique address to each of the devices which are connected to the internet. So whenever the device is connected to the internet, it should be having a unique address which can uniquely identify it. So when we talk about data link layer, we were talking about physical addresses. Now this physical addressing works only in the local network. So when we talk about global addresses, that is common throughout your internet, we are using the IP addresses. So the most common widely used logical addressing is your IP address. It is also known as Internet Protocol address, and it operates in your network layer, which is layer 3. So what is an IP address? An IP address is a numerical label which is assigned to a device which is connected to a network, and that label is a unique label. Now, for example, when you talk about an address, when we talk about our home address consists of our house number and a you can say the locality locality address. And even when you talk about pin code, with the pin code, we can uniquely identify our address. Pin code will have a sub part which will identify the area, and other will identify the sub area. So in the same manner, what IP address also have two parts. First, it identifies the host, and the other part identifies the network location. So whenever we talk about an IP address, it consists of two parts. Like this is suppose this example of IP address. Some of the bits will be depicting the network, and rest of the bits will be depicting the host address, right? So there are two ways by which we are writing an IP address. One is your IPv4 and other one is your IPv6. So IPv4 is a 32-bit address, whereas IPv6 is a 128-bit address. We will be discussing each of them simultaneously. Now, why do we need an IP address? First, it is used to uniquely identify the devices. So, if I have to send a packet to a device, I have to name that packet uniquely. Now, that name is your logical address, right? Unique name. As we all have been assigned, as a student, we have been assigned a roll number. So, each roll number is unique to that person, and that roll number is not been given to anybody else. And also when you see your roll number, you can see the each one part of the roll number will tell your course and the college name, and other part will tell you your serial number. In the same way, the IP address also, a part of IP address depict a network address, and other part depict the serial number of that node in that network, right? Now, there are two types of addresses I have already told. One is your IPv4 and other is your IPv6. Now, IPv4 is a 32-bit address, so therefore, it consists about 4.3 billion unique addresses. So if we have 32 bits, so number of total address possible in your IPv4 is 2 raised to power 32. It means there are 4.3 billion unique addresses. So when it was conceived in 1983, it was supposed that this is enough. But now when every system is connected to the network, we need more IP addresses. This pool has been consumed. For that matter, we have shifted to IPv6 addressing scheme, where we are using 128-bit addresses. So obviously 2 raised to power 128 is equal to 340 undecillion addresses, which are huge number, and it can never finish in our lifetime. So this is the two techniques of your addressing: IPv4, which is 32-bit addressing, and IPv6, which is 128-bit. And these addresses are used to uniquely identify a host in a network. So when we talk about IPv4, it consists of 32 bits. 32-bit means 4 bytes. So address space will be 2 raised to power 32, which is around 4.3 billion. So it can be written in two formats. First is in a dotted decimal, and other one in binary format. So when we represent it in a binary format, we make it as octets. So if its total is 32 bits, and each octet, as the name suggests, consists of 8 bits. So this is my 8-bit, this is my 8-bit, this is my 8-bit, and this is my 8-bit. So this is how I am representing it into a binary format. And I can also convert this binary format into a dotted decimal format, in which I will be taking one octet and I will be converting that octet into a numerical number. It's decimal number, it's 128. So this will represent as 128, this is 11, this is 3, and this is 31, and I will add decimal in between them. So this is a dotted decimal notation, which we usually use in depicting the IP addresses in the IPv4 notation. So how we convert a binary to decimal? It's very simple. I have a binary number, a 32-bit binary number. I will be dividing this 32-bit binary number into 8-bit octets. Now this 8-bit, each of these 8-bit can be converted into a decimal number. It's very simple. Suppose this is my number, I can write it like this, put location wise, and when I will get the sum, right? So like this. So 2 raised to power 7 plus 1 for this is your 128. So likewise, I can find out the convert decimal to binary to decimal, and to convert to binary to decimal is also easy. We can also convert a decimal into binary by dividing it by 2. It's simple technique. Now you can see this is how I am converting a binary into a decimal. This is my binary notation. Right? So what I will do, this is 2 raised to power 0. Okay, then like this. Then what I will do, I will add them. 2 raised to power 6 plus 2 raised to power 5 plus 2 raised to power 4 plus 2 raised to power 2 plus 1. So when I will add, I will get 170. So this is how I am getting this. For each of these octets, I will be converting them into the decimal part. Now, we all have understood till now that we are representing our address as a 32-bit number. Now, to manage such huge number of devices, we have divided the IPv4 addresses, that is a 32-bit number, into different classes. Now, classful addressing in the original IPv4 address location was that we have divided the whole of the address space, that is 2 raised to power 32 addresses are possible. So we have divided this address space into 5 fixed classes like A, B, C, D and E. These are the 5 classes I am going to divide my addresses, and each class will have a fixed boundary, okay, and it will have a fixed boundary between the network portion and the host portion. So as I have already explained that my 32-bit IP address, some bits will be representing the network and some bits will be representing the host. So these classes are deciding the boundary, that which number of bits will be specifying the network and which number of bits will be specifying the host. So like this, my address of 32-bit will be divided into 2 parts, that is network ID and the host ID, and according to the type of class, I will be deciding what number of bits will be representing the network and what number of bits will be depicting by host. So we are now, this system of classful addressing is replaced by CIDR. We will discussing that also later. Now, as I've already told you that according to the class, we will be depicting the number of bytes that will be representing the network address. So when we talk about class A, the first byte of, we have in total 32 bits. Okay, 32 bits means how many bytes? 4 bytes, right? Right? Because 1 byte is equal to 8 bit. So we have 4 bytes. The first byte of the IP address will be reserved for depicting the network in class A. And also, how will we identify class A? By putting the most significant bit as 0 in your network address. Similarly, for class B, 2 byte will represent the network address and rest of the 2 byte will represent the host. In class C, we will be having 3 bytes representing the network address and 1 byte representing the host. In class D and E, we don't have demarcation of network addresses and the host addresses. And also, you can see the values as 0, 10, 110, 110 as these are the indicators of the class. Now, when we talk about class A, now class A says that the first byte will represent the network, and these 3 bytes will represent the host, right? So, if I talk about the first address of this will be 0.0.0.0, all right. And what will be the last address? This bit is fixed, okay. So, this could be the first address, and if we talk right in your last address of this will be 1, 2, 3, 4, 5, 6. Sorry. No. So, if I talk about the first address, it will be this will be my first address for my class A, right? And what will be the last address? Now, last address, you can say this bit is fixed. So, last address will be and so on, 8 bits of 1, okay. So, this will be last address, this will is fixed, fine. So, how many number of hosts are possible? The hosts are possible. Now, this is my first address, this is my last address. The range will start from this. Now, this address is reserved and this address is also reserved, 127. When you convert this into network into a decimal number, you will get like this. So, this is reserved as a loopback address, right? So, if we talk about range, this is a clear, and number of hosts. Number of hosts is, since 3 bytes are depicting the host, okay. So, 3 byte means how many bits? That is 3 into 8, 24. So, number of hosts possible, number of addresses possible is 2 raised to power 24. But since x dot 000 is reserved for identifying the network, the first address will represent the network and the last address will be broadcast address. So, number of hosts will be -2. Alright. So, this is how we are depicting your class A. Now, when we talk about class B, the first address of class B will be 10. This will be my first address, okay. And the last address will be 10. This will be my last address of this class, okay. This one is fixed. So number of networks possible are, number of network is these two. Number of network is possible are, they are 2 bits. So yani 2 raised to power 16, because their 2 bytes are representing the network. So number of network possible are 2 raised to power 16, and number of hosts are 2 raised to power 16 minus 2. Minus 2, why? One is for the network, identifying the network, and other is for the broadcast. So this is my number of network and this is my number of host. When we talk about number of addressing, it will be 2 raised to power 16. So here we are having 65,534 hosts per network. In one network, I will be having 65,534 hosts. So class B network is comfortably accommodating a large campus. So when we are needing for in one network, I am needing 65,534 hosts. We will be using class B. Whereas in class A, we are having around 16 million hosts per network. It's very huge amount. It's very difficult for a single network to get so much host, right? This is very huge. So you can see there is unevenness. In one class A, I am able to put 16 million hosts to one network. In class B, it's only 65,534. That is also very huge. When I talk about class C, we have only 254 hosts per network. This is very small for even small businesses. So here also, the first address will be right like this, and last will be and so on. So here also number of possible networks is this and number of hosts is 2 raised to power 54, right? So you can say 1, 2, 3 number of, so these are my number of possible networks and number of possible hosts. So you can see this is very less, 254 is very less. If my number of hosts are huge in my network, it will be very difficult to cover in class C. In class D, basically we are reserving it for the multicasting where it is depicted by 1110. So we are putting in the 4 most significant bit as 1110. It is never assigned to individual devices and it is only used for multicasting. Whereas class E, here the leading bits are this. This is fixed and it is used for the experimental or research purposes, right? So what are the problems of classful addressing? First of all is massive IP address wastage. When you talk about class A, we are putting around 17 million addresses into one network. In class B, we have around 65,000. In class C, we have around 254. So we can see there's a massive wastage of addresses. So if my organization is say have only 5,000 hosts in my network, so I cannot choose 250 for class C. I have to choose class B. So class B also my many addresses are being wasted. So you can see we have inefficient address distribution because in class A I am having millions hosts, whereas in class C I have only 100 hosts. So the result of this is we have rapid address exhaustion. Now we are trying to resolve this issue by using subnetting. Subnetting means we have a large network, we are dividing the large network into smaller subnetworks. Now there are many benefits of subnetting, which includes we can reduce the network congestion by limiting the broadcast domain. So if I am dividing my big network into smaller networks, what happens when I broadcast a message, then obviously my message will be only limited to the subnetwork and it will not go to the whole network. Second, it will also improve security, and third, it will lead to efficient use of IP address. Also, when my networks are small, it is easier for me to manage them. Now, subnetting works by borrowing bits from the host portion. So, what I am doing, this is my IP address. Now, IP address consists of 2 parts. First is network and other is host. So, what I can do, I can reserve some bits of host to identify my subnetwork. Now, this is basically called as subnetting. The host identifier, we are divided into 2 parts. One will represent the subnet identifier, other will represent the host identifier. So, similarly to depict the subnetting, we are using the subnet mask. So subnet mask is a 32-bit number that separates the network portion from the host portion of an IP address. So basically, subnet mask will tell you number of bits in your IP address which is depicting the network. So if I talk about class A, here my 8 bits is depicting the network. So I am writing /8. Here my 16 bits are depicting the network. So I am writing 16. Here my 24 bits are depicting the network. So I am writing 24. In binary format, I am writing like this. So when I do AND with my address, I could find out this portion of bits will tell me my network and this portion of bits will tell me my host. So if I convert this is subnet mask. This is how we present as subnet marks. Those positions which will depict the network, we will put it as 1 like this. Here, first 2 will depict as network. Now, I am converting it into dotted decimal, right? Now, we have to understand that classful addressing is being difficult. Why? Because there is exhaustion of addresses because of the uneven distribution of classes, of hosts in the classes. Therefore, we have shifted to classless addressing, in which we have stopped using the different classes. Instead, we are using the concept of blocks. So, we have divided our network not as a, you can say classes, but in the side of blocks. So, in classless interdomain routing, the IP in this, we are allocating IP addresses to variable size blocks. So, there are no concept of networks, it is a concept of blocks. So, blocks could be any of size power of 2. Okay, we are writing as like this, x dot y dot slash n. N will depict the subnet mask, which will represent how much number of portion of this will be representing the block. So, the restriction of a valid CIDR block is first, contiguous addresses. The addresses in the block must be consecutive. There should not be differences. Block size should be power of 2. The first address divisible will be the block size. Now, if I have to find out the first address in my address mask, what I will do, I will AND the address with the mask. For the last address, I will be ORing the address with the complement, and this is my number of addresses. Now, we will try to understand this with the help of an example. Now, see, this is this address I am given, and here it is written a block of addresses. Okay. Now, the block of addresses means we are here using classless interdomain routing, in which we are not using the concept of class, we are using the concept of blocks. Now, in blocks, how can we identify in this address how many bits are representing my network and how many bits are representing my host? Now, to understand how many bits in this address is representing my host, I have to check the subnet mask. Now, the subnet mask over here is 28. It says that 28 bits in my IP address is depicting my block, and rest 32 minus 28, that is 4 bits, is representing my host. The first, it is asking me the first address and the last address and the number of total addresses. So, to get into this, I first have to convert this into a binary format. Now, this is my dotted decimal notation. I will be converting them into the binary format. Now, I have converted this into binary format like this. This is the binary format. Okay. 205, we are converting to 205 into binary. Then 16 is this, 37 is this, 39 is this. Now, I have to find out the first address. Now, first address means we have to find out the first address. What does it mean? It means that first I have to identify the network address or the block address. Now, how will I identify block address? I will have to find out the subnet mask. Now, if I convert this into a binary notation, I will get the subnet mask. Now, here it's simply depicting that I have thus 28 bits in this. In this, 28 bits are assigned to the block and rest 4 bits are assigned to the host. So if I count, this is 8, 8, 16, 24 and 4 bit here. So this portion, you can say this portion is your block and this 4 bits is representing the host. Alright. So if I have to convert it into the first address, what could be the first address? This will be same, right? I will be repeating this. And then I will putting these as 0. This will be my first address like this. You can see. This is whole copied down and this 4 are my representation of a host. So to get the first address, I will giving them as 0. So this is my first address. Now to get into dotted decimal part, I just have to convert this binary part into the dotted decimal. So it will be first address will be come out. I'm just converting them into the dotted decimal part. Okay. Now I have to find out the last address. So what will be last address? This host part. This is fixed. I cannot change this. Network part I cannot change. For host, what will be the last host? When all these values will be 1, 1, 1, 1, 1. So all these will be 1, 1, 1. So this is my, here we have converted. This is as is and last one is as 1, 1, 1. So what will be what will be number of addresses last host? This will be my last address. This will be my last address. By putting all the bits of host to 1, we are getting the last address. By putting all the bits of host to 0, we are getting the first address. Simple. So whenever you receive get a subnet mask, what you will do first step is to convert the dotted decimal into binary part, and then we have to fix the number of bits that is written over here as subnet mask. We have to fix that. That is your network part. Rest of the bit, we will put it as 0. When we put it as 0, this will be my first address. And if I put all the host bit as 1, this will be my last address. And what are the number of hosts? It will be 2 raised to power 32. That is my total number of addresses minus 28. Because this will be the host only, na? Only 4 bits are there, which is representing my host. So what are number of possible hosts? 2 raised to power 4, or we can say 16. Now this is my answer, number of hosts, right? So there is another method of using mask as using by AND or OR. We just have to, you can say, convert the mask into a binary representation. Okay, so I have been given 28, right? Now what I will do, in earlier, that was one way. The other way is, we are converting this binary number into a decimal number into a binary number. Okay, so this is my binary number. And then next step is to convert the subnet mask also into a binary number. Okay, now we have converted 28 into mask of a binary number. How? This is 28. It means there are 21 ones in my mask. So what I have done, 8, 16, 24 and 4, 28. So these first 28 bits, most significant bits, I have put it as 1 and rest as 0. This is my subnet mask. This is representation of 28. 28 means there are 28 ones in my mask. So 28, I have set the MSB 28 MSB bits as 1, right? Then what I'll do, I will AND the mask with the address to get the first address. Alright. So what it will do? It will set the first address as and this will be 000. So this will be my first address. Okay. For the last address, I will be again using the mask and the address, and what I will do, I will complement the mask. Here, I will be complementing the mask. This is a mask, I will be complementing the mask. And then I will be ORing my address with the complement of the mask and I will be getting the last address, right? Now, how to get the number of addresses possible? What I will do? I will complement the mask and convert them to decimal and add 1. So, what I have done? I have complemented my mask and added 1 to get my total number of hosts. So, it is as simple as that. First, you have to understand the basic thing that the subnet mask is that we are depicting over here represent number of network bits in my address. That is a simple line that you have to understand. The subnet mask will represent the number of bits in your network. So, with this, you are able to solve every problem. So, first address will be we are fix the network address and putting all other bits to 0. That will be my first address. If I put all the bits to 1, that will be my last address. And the number of bits that is represented by host, we are putting that 2 raised to power that number of bits of host is equal to number of hosts possible. So, this is how we are solving these subnetting questions. Thank you.